name is Daniel. I work with Nervos Network, and we're a UTXO chain that has layer 1 and also has a layer 2, which is EVM compatible. We are probably operating a first EVM compatible optimistic rollup on a UTXO chain since like probably half a year right now. So we deployed last version of this rollup last year, but we have a new version that's ready in testnet and will be coming in 2 months probably to mainnet. So yeah, I will speak about this optimistic rollup and our challenges building this optimistic EVM compatible rollup on the UTXO chain. So I'm in the blockchain space since 2017. Previously, I worked for Ethereum Alarm Clock, Polymath, so it was like security tokens, and Energy Web Foundation, which was energy and blockchain. So first, I'll talk a little bit about our layer 1, because it's very important when we are looking at our layer 2, especially the virtual machine that we have on our layer 1. So yeah, then we'll talk about our layer 2. So first, what is Nervos Network? So everything we build here is coded from scratch. We have our own research team, own developers, and yeah, they design it. Our top researcher, he used to work in the Ethereum Foundation. At the time, I believe he worked on sharding, and then he left, I guess, in 2019 to build his own blockchain, Nervos, and the idea was to build Nervos from the ground up with this layered architecture in mind, not actually like in Ethereum it was built probably we didn't know that we will have many layers when the Ethereum was built. So that was built with this layered architecture in mind. So yeah, we are a proof of work. We believe it's the most tested and secure at this point. We're also a UTXO chain. We have smart contracts capabilities. We already have mainnet applications on our UTXO layer 1 chain. And apparently there's only 11 active blockchain projects that were published on top security conferences in the world, and we're one of them. There are others like Arbitrum, Cardano, Bitcoin, and yeah. So yeah, we were built with this layered architecture in mind from the ground up. Everything was coded in Rust actually. And yeah, our layer 1 is supposed to be very minimal, just for verification. There's no state generation on our layer 1. It's a UTXO chain. And we leave everything, the state generation, we leave it for the layer 2. Our layer 1 was designed like this. And yeah, so it's supposed to be minimal and just a place where we anchor all the layer 2 solutions. And really interesting thing, which is different to what people talked yesterday and today, and even Optimism mentioned RISC-V. So the Optimism is running they cloned Geth, and they're running it on MIPS RISC virtual machine. And they mentioned RISC-V. So we actually have RISC-V on our layer 1 in mainnet, and this is where we deploy EVM. Which secures our optimistic rollup on layer 2. That's why we inherit security from our layer 1. We are still our rollup also has training wheels, it was said on the panel yesterday, but we obviously have a plan to decentralize it. So yeah, it's a RISC-V, so you can potentially deploy different VMs, not only Ethereum, but I don't know, let's say some other ecosystem explodes, or we want to, just enable people to interact between EVM applications and maybe some other virtual machine applications. So that's our goal basically. We can plug in anything. So Godwoken is the current name of our optimistic rollup that's already on mainnet. We have 80 million TVL, and So the key features and the vision for our rollup is to actually enable users to just use the wallet they are actually using today. So for example, we can imagine that, for example, we have Ethereum user, and this person only uses his MetaMask. So we want this person to just go to any dApp and be able to use MetaMask wallet, and so minimal friction, best UX for people. And the same goes, for example, for, let's say, a Cardano or Tron. So there's a Cardano user has Cardano wallet. He goes to this application and is just able to use the Cardano wallet while interacting with this application. And this is also possible because we have very flexible architecture of our rollup. So we can do these like different cryptographic verifications on our layer 1 because it's just like RISC-V. So RISC-V is just like standard for instructions of the processor, I believe, and it's widely adopted beyond blockchain space, right? So I think it's really important because we can import Rust libraries on our layer 1, so we don't have to code everything from scratch. We can reuse. So yeah, actually on one of the previous presentations, one of our developers deployed JavaScript, duct tape. This is like a version that compiles to RISC-V, and people were able to just, build JavaScript smart contracts in addition to Rust, or this was actually running on layer 2, so in addition to EVM. So this is really interesting. And yeah, the idea is to also have like different wallets. And so how our optimistic rollup is built, actually, we are using Ethereum C++ implementation that compiles to RISC-V, and yeah, this is deployed on our layer 1. Yeah, this is just, I don't want to talk about the same things as other people talked in the other presentations. This is just like a basic diagram, how the block production works and how it's committed later to layer 1. So we deployed our mainnet mainnet optimistic rollup last year, and there are some lessons that I want to share with you. So our first version was called V0. So yeah, we started counting from 0. And we were 95% EVM compatible. But it wasn't enough because we found all these teams that wanted to build applications on our EVM network. They really needed like very close to 100% because they are maybe using some calls, some RPCs and stuff like this. And if it turns out that if you don't build something that's like almost exactly as compatible as Ethereum, then they have to rewrite their code, and they maybe not necessarily want to do this kind of stuff. So instead of so it was easier for us just to build something that's more EVM compatible, and that's what we did. We already have more compatible solution that's already in testnet, and yeah, it will probably be on mainnet in like a few months. Yeah, so this was the most important lesson. And yeah, our security model right now is, so we are optimistic rollup, but we still have like a centralized sequencer. So we obviously want to decentralize it. For our mainnet, we are running mainnet beta. So actually deploying smart contracts is whitelisted. So you have to apply through a form, and then we allow you to deploy smart contracts. And yeah, we already have like some DEXs running there. For example, people can bridge from Ethereum on mainnet to our layer 2 chain, to our layer 1, then to our layer 2 chain, and it all works on the UTXO chain. One of the things that I want to also mention for UTXO chains, why optimistic rollup, EVM compatible optimistic rollup is more important for them maybe than even for Ethereum, is on the UTXO chain, you have a different programming model than in Ethereum, because Ethereum is like account-based model, and all the programmers are used to just program in Solidity and use this account-based model where they have this like state that can be changed multiple times in the same block. And in UTXO, it's really different way of programming. That's why we see, like, for example, Cardano is also a UTXO chain, and it's a new ecosystem. People need to learn how to build smart contracts on the UTXO chains, and this is a challenge in itself. So yeah, right now we only allow like authorized sequencers to operate. In reality, we have a single sequencer right now who's producing blocks. We have a challenge system. We have a logic for a challenging in place, but we actually didn't, because it's still like not everything is decentralized yet. But yeah, in theory, it should be implemented already. A challenge system and slashing. So yeah, we are going step by step here. It was already a huge challenge for us to like build all these interfaces because we didn't clone Geth. And so, for example, we had to build all the RPCs, all the APIs, and stuff like this. So first we spent like 2 years building our mainnet, a UTXO chain. Then we basically spent another 2 years building our optimistic rollup that's EVM compatible. So right now we can really just focus on getting projects to build on this stuff. So yeah, why you should care? We are working with some other UTXO chains, yesterday, for example, on the presentations, there were also some ideas by people from Ethereum Foundation and Arbitrum and few labs how we can scale Ethereum further and the challenges that are blocking us right now. And one of the things that were mentioned was like parallelizing computation. So we already have this, at least in our layer 1, because we are a UTXO chain. So the access lists that were mentioned in the opening keynote, we have this by default. And the second thing was from the yesterday's presentations was state rent for state. So we have like storage. Basically, on our chain, you have to pay for every byte. You log bytes when you deploy a smart contract, and then you de facto pay for it because we have an inflation. So yeah, we have a state rent mechanism. And yeah, we are working with top UTXO blockchains in the space to address some common challenges for our layer 1. Yeah, as I said, we have a state rent mechanism implemented. So yeah, we just are going through the hard fork right now. We upgraded our RISC-V virtual machine. On layer 1, you program in Rust. So basically, the current hard fork enables you to just use more features in Rust programming language. We want to build another sidechain this year, specifically focused, for example, on gaming. Yeah, we try to be a future-proof blockchain, so really not like only looking at EVM, but also looking at what future can bring. That's why we have this very flexible virtual machine that we can deploy various stuff there. And yeah, we already have some bridges like Ethereum, Binance Smart Chain. We're working very hard on the Cardano bridge, but it's not easy. And we really want to focus on this this year. And yeah, we want to also support multiple locks. This is just like example of like Cardano lock working on our testnet. We were also looking at the Bitcoin Taproot upgrade, which gives some more like smart contract abilities to the Bitcoin protocol. We also partially implemented this on our protocol because as we said, we have this virtual machine. And yeah, so we invite anyone to build on our chain. We have hackathons, grants, accelerator program, and yeah, just looking to kickstart this ecosystem. As someone from Diversify mentioned before, there are like 2 approaches if you build new EVM ecosystem. One is you can just like port these applications and spend money on getting them to your chain, or you can become a hub like Cosmos is doing, right? For us, I think we really want to become a hub and have the best UX where people just can stick to their wallets, and we don't want to sacrifice security. We believe it's really important, and also I have seen some projects presented on these stages around these conferences, you know, taking compromise in security, and the audience was always like very harsh on like all the security compromises. So I think especially for this audience, it really matters. So we don't want to compromise on this at any layer basically, but it's a step-by-step journey. So yeah, it's already, our rollup is already working. It's on mainnet. There will be new version coming, more EVM compatible. Yeah, just join our community and maybe learn more about UTXO chains. And I think this is also interesting, the direction that wasn't mentioned too much. But I know some companies are using UTXO. I think Aztec, we talked yesterday, under the hood, and Fuel Labs as well is using some form of UTXO. I don't fully understand every technical detail, but yeah, UTXO, smart contracts, and that kind of stuff is also around. So probably worthwhile to keep an eye on it. So yeah, more bridges, more wallets, more decentralization, potentially ZK. That's it. Thank you. Thank you so much.
Questions?
Hi. So you mentioned you have a concept for state rent, right?
Yes.
And you're talking to the Ethereum Foundation. Do you think some of the concept that you have can be integrated into like an Ethereum type network, or?
So we are not, I don't think we are in contact with Ethereum Foundation. Our top researcher worked there a few years ago, but then he left. I think he was working on sharding back then, but then the whole idea for sharding in Ethereum, I think it was changed. Right now we are looking at a different sharding, which was mentioned multiple times yesterday, like this proto-bank sharding and more like modular rollup architecture. So I think that might be inevitable for like in future for Ethereum to introduce some kind of like state rent, but we are unfortunately not in talks with Ethereum.
And do you think this mechanism, so you didn't really talk how this mechanism works, but I remember that Nervos was kind of advertising this a lot in the beginning because it was kind of special that you focused on this, and that your token is also like focused on this idea of paying for state instead of focusing on computation.
Yeah, I think that's important. I think, I'm not sure who mentioned this, Fuel Labs or someone else, but you know, yesterday there was this example of gas token on Ethereum, right? And I didn't even know that the state grew from like, I don't know, 30 gigabytes to 100 gigabytes just because of this token, right? So because we built the layer 1 protocol from scratch, from the ground up by our researcher, we have custom consensus model, a custom hash function, and we were able to see the challenges that Ethereum had already. So we have this like, you know, state rent. So basically you lock, like, let's say your smart contract takes 10 bytes, you have to lock it when you deploy it. When you destroy it, you can get your like 10 bytes tokens back. And you pay because there's like an inflation mechanism, 3%. But yeah, I don't want to talk about tokenomics because I don't want to like advertise our project specifically.
Okay, thanks.
And to clarify, the state rent only works on layer 1, not the rollup.
Right? Yeah. We have a lot of people from community asking about like the state rent, like how would this work on layer 2, and they have like lots of amazing ideas, but we didn't implement any mechanisms yet.
Any other questions? Okay, thank you.
Thanks so much.